Welcome to the final part 3 in our semester 1 final review. Let's look at number 19. It states in 1990 the population of Kenosha, Wisconsin was 132,000. For several years the population increased by about 2,000 per year. So it says write a linear model. So our linear model that we're most familiar with is y equals mx plus b. And what I would start with is deciding what the rate is, because we know that the rate and the slope are going to be the same. So if I look up here at the writing, my rate is going to be right here, the part that says 2,000 per year. So I'm going to have y equals 2,000 x, and then the other piece of information that we need is the starting point. At this place, at this time, the starting point is 132,000. Number 20, it says, what would the population in Kenosha be in 2014? So we look at 1990, and we're going to say 2014 minus 1990. And this is going to be how many years? 4, borrow, and that would give me 24. So now I'm going to take 24 and I'm going to plug it in for x. So what I have here is 2,000 times 24 plus 132,000. I'm going to do this part first. 2,000 times 24 is going to be 48,000 plus 132,000. Add those together, I get 180,000. So on number 1, we're talking about the lowest elevation in Mexico is negative 10 meters at Laguna Salda. Write and graph an inequality that describes all elevations in Mexico that are greater than the lowest elevation. So we'll have x, and x is actually going to represent our heights, or elevation in Mexico. And we know that all elevation is going to be greater than or equal to negative 10. Now to graph this, here's negative 10. This would be negative 11. This would be negative 9. This is going to be a closed circle, or shaded in, at negative 10, and it would be going in this direction. And that is how I would do number 1. Now we're going to start with number 2. We're going to graph the inequalities. So I'm going to minus 5, minus 5. That's going to give me x is greater than negative 18. Here's negative 18, negative 19, negative 17. Open circle going to the right. Number 3, I'm going to add 9 to both sides. That's going to give me m is greater than or equal to 5. We'll use this graph down here. Here's 5, 6, 4. Shaded in circle going to the right. And that's how I would do 3. Number 4. Instead of dividing by 2, I'm going to multiply both sides by 2. That would cancel, leaving me with p is less than or equal to 10. If 10 is here, this would be 11, this would be 9. This is going to be a shaded in circle going to the left. Let's take a look at number 5. I don't know where it went to. There it is. So once again, instead of dividing by a negative 4.5, I'm going to multiply by a negative 4.5. So that all cancels on the left side. It would give me n is less than. Negative times a negative is a positive. Let's see, 4 times 8 is 32. And then we have half of 8, which is 4. I'm going to get 36. There's 36. And 35. And 37. Open circle, going to the left. Number 6, instead of multiplying by -3, we're going to divide by -3, remembering that when you multiply or divide by a negative, you have to flip your inequality. So I'm going to get x less than -9. -9, -10, -8. Open circle, going to the left. Number 7. Instead of multiplying by 2, we're going to do the inverse of multiplying by 2, which is dividing by 2. That gives me y is greater than or equal to 9. 9, 10, 8. This is a closed circle going to the right. Let's take a look at the next problems. Number 8. To start this one, this is a two-step inequality. I'm going to start by getting rid of this plus 11. So I'm going to minus 11 from both sides. That gives me 2g is less than 14. Then I'm going to divide by 2. I get g is less than 7. I'm going to just graph this quickly. Here's 7, 8, 6, open circle, going to the left. Once again, this number 9 is a two-step equation. I'm going to get rid of that first. I'm going to add 4. Add 4. That gives me 2/3 r is greater than or equal to 5. And now to get rid of this 2/3, I'm going to multiply both sides by the reciprocal. That all cancels, leaving me with just r on the left side. R is greater than or equal to, and there's nothing that we can cancel on this side, so multiplying numerator times numerator would give me 15, denominator times denominators would give me 7, or r is greater than or equal to 7.5. So here's 7.5, here's 8, here's 7. Shaded in circle, going to the right. Number 10. I want to get my variables on this side. So in order to do that, I'm eventually going to move this 2 over here by minusing 2x. But before we do that, I'm going to look for any addition or subtraction. And my numbers, I want my numbers to go over on the right-hand side. So I'm going to get rid of this positive 1. I'm going to minus 1 from both sides. That would give me -3x less than or equal to -15 plus 2x. Now that I have my numbers on the right, I'm going to try and get my variable over on the left-hand side. I'm going to minus 2x from both sides. That's going to give me -5x less than or equal to -15. Now I'm going to divide by -5 on both sides. That's going to give me x. I'm going to flip the inequality because we divided by a negative. And I get x is greater than or equal to 3. 3, 4, 2, closed circle, going to the right. Alright, number 11 and number 12, both of these have severe errors, and I'll just tell you straight off, these are unsolvable. When you do the distributive property on number 11 and you get 3q plus 1 is less than 3q plus 3 after you distribute it correctly, is less than 3q plus 7. If you minus the 3q from both sides, you get rid of your variable and you're left with something like 3 is less than 7, which is true, but we have no variable. Typically, we called this no solution, but I'm just going to tell you that straight up this is an error on this review. So don't worry about it. Number 12 is the same. When you do the distributive property correctly, you get 8t minus 8 is greater than 8 plus 8t, which doesn't make any sense because knowing that these are terms, we can reverse them, and you'd end up with 8t minus 8 is greater than 8t minus 8, which doesn't make any sense because those are equal to each other. So we're just going to call this one an error. And my apologies, I didn't catch that earlier. Number 13 is not an error. So we are going to distribute the negative 3, so that would give us negative 3 times 2n is negative 6n. Negative 3 times negative 1 is positive 3, is greater than or equal to 1 minus 8n. I'm going to add 8n to both sides. That gives me 2n plus 3 is greater than or equal to 1. Now I'm going to get rid of this part, so I'm going to minus 3. I get 2n is greater than or equal to negative 2. Now I'm going to divide by 2. I get n is greater than or equal to negative 1. So here's negative 1, here's negative 2, here's 0. This is going to be a shaded in circle going to the right. And that's how you do 13. Number 14 says you can order discount movie tickets from a website for $7 each. You must also pay a shipping fee of $4. You want to spend no more than $40 on movie tickets. Write and solve the inequality to find the possible number of movie tickets you can order. So we know that they're $7 each. So this is going to be 7x. And there is also a one-time $4 fee. And we know that this amount has to be less than or equal to 40. Because we don't want this amount to be more than, we want it to be less than the amount of cash that we have. So now to solve it, we'd minus 4 from both sides. That gives me 7x less than or equal to 36. Divide by 7 on both sides. We get x is less than or equal to 36 divided by 7 is 9. So we would be able to order 9 tickets. The possible number is 9 tickets. All right. Number 15, tell whether it is a solution. So our 2 is our x, our 8 is our y. So I would have negative 3 times negative 2 plus 2 times our y, which is 8, is greater than or equal to 16. And so negative 3 times negative 2 is positive 6, plus 2 times 8 is greater than or equal to 16. And so I've got 6 plus 2 times 8 is 16, so I get 6 plus 16 is greater than or equal to 16. So I get 22 is greater than or equal to 16. So the answer to 15 is yes. It is a solution. Now let's erase this and we'll do number 16. Number 16, my x value is 9 and my y value is negative 5. So I would have negative 3 times x, which is 9, plus 2 times my y value, which is negative 5, is greater than or equal to 16. Negative 3 times 9 is negative 27, plus 2 times negative 5 is negative 10. That's going to give me negative 37 is greater than or equal to 16. And this answer is false. So I would put not a solution. And that's how I would do 15 and 16. Here is number 17, graph the inequality. So it's already set up in slope-intercept form. Here I have my slope. So I know my slope is going to be 2 over 1. And my y-intercept is going to be 3. So I'm going to start there. Y-intercept is 3. I'm going to go up 1, 2, 3. Put a dot. From that point, I'm going to apply my slope. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and down 2 to the left 1. And I look at my inequality. If it's less than or equal to, it's a solid line. Or greater than or equal to, it's a solid line. If it's less than or greater than, it's just a dotted line or a dashed line. So here is my dashed line. Now I have to figure out which side I'm going to shade. So I'm going to test 0, 0, because I can see that 0, 0 is clearly on one side. And so I'm testing this whole side to see if it's true or false. So the way that I do that is I plug in 0 for y and 0 for x. So 2 times 0 is 0. 0 plus 3 is 3. And y is just 0. So I'm asking myself, is 0 greater than 3? And the answer is no. So this is my false side. That means the other side has to be the true side. And so I would shade the other side. And that is how I would perform the correct operations for number 17. Let's take a look at number 18. Number 18 is also already in slope-intercept form. I'm going to start by putting my y-intercept, which is right here, as negative 1. And then I'm going to do my slope, which is negative 1/2. Which means I'm going to go down 1 to the right 2. 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 Or up 1 to the left 2. And then because this one is less than or equal to, this one is going to be a solid line. So make sure that I'm going to connect my dots here and make a straight line. Now I'm going to test which side. But because 0, 0 cuts so close, I'm going to pick 3, 3. So I'm testing the location 3, 3 to see if it's going to be true or false. So my y value is 3. I get 3 is less than or equal to negative 1/2 of 3. Well, half of 3 is 1.5. So the negative of 1.5 of 3, half of 3 is a negative 1.5 minus 1. So I get 3 is less than or equal to negative 2.5. So is 3 less than negative 2.5? This is my false side. So if this is the false side, the other side is the true side. And so I'm going to shade the true side. And that's how I would do number 18. On number 19, this one is not set up in slope-intercept form, but what I'm going to do is I'm going to solve this using the cover-up method. So when my x is 0, negative 2 times something equals positive 6. So I know that's going to be, negative 2 times something equals positive 12. I know that's going to be negative 6. And then when my y is 0, I have 3 times something equals 12. So that one's going to be 4. So I'm using my intercept. So if I go over 0 down 6, it would be about right there. And then over 4 up 0. And then this would be my line, and it would be a dashed line. Then I'm going to do the same thing. I'm going to test 0, 0. So I'm going to test this location. So I'm going to put a 0 in for x, and put a 0 in for y, and see if it's true or false. 3 times 0 is 0, minus 2 times 0 is 0. I get 0 is less than 12. So this time, 0, 0 is on the true side. So I'm going to shade in this portion of the graph. Let's move on to number 20. Number 20, y is greater than or equal to negative 5. So this has no x value. So I know it will never cross the x-axis. So that means it has to be a horizontal line that crosses the y at negative 5. 1, 2, 3, 4, 5. And this one is going to be a solid line. Then I'm going to check a y value. And I'm going to check a y value of 0 because it's the easiest to do. So my y value of 0 means that I put 0 in for y. Is 0 greater than or equal to negative 5? And the answer is yes. 0 is greater than any negative number, and certainly negative 5. So I would shade the part that has the 0 in it. And that's how I would do 20. 21, I'm going to start by trying to get my variable by itself. So to do that, I'm going to add 5 to all 3 parts. Negative 1 is less than or equal to 2t less than or equal to 2. Then I'm going to divide everything by 2. So that gives me negative 1/2 less than or equal to t less than or equal to 1. Now to graph this, we can graph one part very easily. The part that we can graph really easily is this part right here. So I'm going to just graph that part. So here I have, we'll call this one 1. And this would be a closed circle or shaded in circle. And the direction is going in this direction. So then we go 1. This would be a half. This would be 0. This would be negative 1/2. Now, the second part is we're going to flip this. So if you take that and you flip it, you would get t is greater than or equal to negative 1/2. So this would be also a shaded in circle at negative 1/2 going in this direction. And this is a classic example of an and. Let's take a look at the next problem. Same type of problem as the last one. I'm going to start by minusing 1. From all 3 sides, I get negative 6 is less than 3x less than 9. Now I'm going to divide everything by 3. So I get negative 2 less than x less than 3. Once again, this is the easy part. So we're going to go right there, and we'll say this is my 3. It's going to be an open circle. The direction is going to the left. The part that's harder is this one, but I'm just going to flip it. So I would have x is greater than negative 2. So here's 3, 2, 1, here's my 0. Negative 1, here's negative 2. Open circle again. And these two are going right at each other. Again, this is an and. (23), these are two separate. Because they're ors, they're two separate. So I'm going to focus on this part right here. And we need to get s by itself. So I'm going to add 6 to both sides. That gives me 9s is less than 18. Divide by 9. s is less than 2, or, and then I'm going to work on this side. Minusing 1, I get 3s is greater than 12. Divide by 3, I get s is greater than 4. So when we go to graph this part first, I've got a 2. Let's put the 2 right here. This is going to be an open circle going to the left. This is 3, this is 4. And now to graph this part, I would have an open circle at 4 going to the left. Classic OR. Number 24 is the same thing. It's ORs. And so I'm going to start with the left side. I'm going to minus 12 from both sides. Negative 4w is greater than or equal to negative 2. Then I divide by negative 4 on both sides, making sure that I flip my inequality so I'll have w less than or equal to a positive half. Now I'm going to go over to the right equation, and on this one I'm going to add 14 to both sides. That gives me 5w is greater than 10. Divide by 5 on both sides. I get w is greater than 2. So now let's graph this. Let's do, here's a half. Here's 1. This will be 1.5. And this will be 2. So if I graph this part here, I would have, at half, I would have an open circle going to the left. And now on the right hand side, I would have an open circle going to the right. And that's how I would do 24. Here are the last 3 on the review. We have absolute values, so that means that I'm going to have 2 answers if you think about the iceberg. So we have 6m plus 1 is greater than or equal to 2. And we also have 6m plus 1 is less than or equal to negative 2. So I'm starting with the equation on the left. I'm going to minus 1 from both sides. That gives me 6m is greater than or equal to 1. Then I'm going to divide by 6. I get m is greater than or equal to 1/6. That would be one of the solutions. Starting with the second part, the equation on the right, I'm going to minus 1. I get 6m is less than or equal to negative 3. Divide by 6. I get m is less than or equal to a negative 1/2. And those would be my 2 answers for number 28. 29. Once again, because it is an absolute value, it's going to have 2 answers. So our first one is going to be 3g minus 2 is less than 5. And then we're going to have 3g minus 2 is greater than negative 5. So if I start with the one on the left-hand side, I would add 2 to both sides. That gives me 3g less than 7. Divide by 3 on both sides. That gives me g is less than 2.5. That would be one of my answers. Now on the right-hand side, I would add 2 to both sides. That would give me 3g is greater than negative 3. Divide by 3 on both sides. That gives me g is greater than negative 1. All right. One more to go. My 2 equations are going to be 3x plus 5 less than or equal to 18. And the other one is going to be 3x plus 5 is greater than or equal to negative 18. Starting with the one on the left, minusing 5 from both sides gives me 3x less than or equal to 13. Divide by 3. X is less than or equal to 4 1/3. now to the one on the right, I would minus 5, that gives me 3x greater than or equal to negative 23. Divide by 3 on both sides, I would get x greater than or equal to negative 7 2/3. So these would be my two answers. And that's it for the final review, folks. If you have any questions beyond what you see in these 3 videos, make sure that you ask Mr. Wanless before we start the final on Friday. Good luck.